coming up with the two-stage design concept, the tools as well. So I'm going to just quickly start off. So I've termed this alternative best management practice to include both of those options. But I want to get started by talking about the need for drainage. I knew I was getting quite a few different types of folks. Some people I might not have to do much convincing that, you know, we need drainage. These practices could apply in urban areas, but here today I've primarily focused on the ag setting. I don't know, as I drive across the landscape, going to our different research sites or back home, I notice an amazing amount of tile drainage going in systems in my county, which is about 70 miles north of here, where there used to be just a little bit of random drainage to drain the low spots. People are replacing with systematic drainage, and you know, one of the things I hear is that, you know, they need outlet for this, they need capacity, and it really, haven't bought into it, does make a huge difference in crop production. In the bottom right, you see two plots. All the management was the same on those two plots. The varieties, fertilizer input, exactly the same. The only difference, one plot had drainage and the other didn't. So to accommodate this in flat landscapes, where you put in the subsurface drainage, it has to have an outlet. For about the past 150 years, this is a type of drainage ditch that's been constructed, often called the trapezoidal or threshold channel, NRCS might call it, where essentially you create a trapezoidal shape, usually bottoms 4 to 10 feet wide, side slopes can be 1 to 1, 2 to 1. And every so often, those will fill in, and there needs to be a maintenance activity to take that sediment out to restore the capacity of that drainage system. So you see what the ditches look like. So I just want to take a quick moment to talk about what most natural streams in this setting will look like. So in low gradient, upper Midwest, a natural stream system would typically have a main channel that contained all of the low flows, and then a floodplain where the larger flows would come out, spread out across, usually a vegetated floodplain, often many, many times per year. We also know that natural stream systems they're self-sustaining. You know, there's some erosion and some deposition, but over time they're fairly stable. They may move around a bit, but over time they generally don't get much wider or fill up. So natural streams are self-sustaining. So we, probably 25 years ago in Illinois, a professor started noticing that in the bottom of the trapezoidal ditches, in some of them, small channel floodplain systems were forming. And this would kind of describe, this is what we call a channel evolution model. So if a stream is disturbed, how might it react to recover to a more natural state? So up in stage 1, you can see this would be kind of your natural channel system. The stage 2 is typically what would happen because somebody has constructed a trapezoidal ditch. So somebody's come in with a backhoe, pulled that out. The channel will typically react in one of 3 ways to that disturbance, because that's not a natural form. It has enough energy, and the bed sediments aren't resistant to that energy, it can downcut. If it downcuts, it may make the bank steep and they can fail. If the bed's resistant to that energy, but the banks are, it can just start widening. And through those processes of erosion, it becomes wide enough. At some point, there's not enough energy, and there'll actually be a deposition of material, which will be building the floodplains back up. And then stage 6 is the final. This here, actually, if you look at the bottom right corner, there's a picture. That was a ditch that was constructed as a trapezoidal channel, and through these natural processes, through this channel evolution, actually built the two-stage channel on its own. showed you the picture of what the current, I guess the current method is, the trapezoidal channel. Here are 3 more recent management practices that you could use to manage drainage channels. First one being the 2-stage design, and I'll go through that in a little more detail. Next one is the self-forming, which Dan is going to show you some examples of. And then before those were even around, there's another approach called natural channel design. So some of you familiar with stream restoration, that's what natural channel design is. And usually that involves construction actually of the channel, so there's shaping of the channel, oftentimes making a sinuous meandering pattern, oftentimes adding a lot of rock or substrate. This might be a pretty good approach if a channel is subject to incising, because you get some great control. Also, if you're looking for a lot of habitat features, perhaps you want to improve some sort of biological community, adding some of that substrate may get you there a little quicker than some of the other methods. But all of these actually come with trade-offs, and I'll identify some of those later. So let's just focus really quickly on the 2-stage. Obviously, the bed would be the bottom of the bed up to the little floodplain area. We call it the inset channel. That would be the first stage, and we can size that based upon what we think nature would like to create. So we know in natural stream systems that if you have a small drainage area to a point, you'll typically have a small channel. And as you go downstream, the channel typically gets larger. Well, we can go throughout a watershed and measure that and come up with a relationship that can help us try and determine how big that first stage might be. The second stage is essentially where the flood flows will go. The nice thing is they go up, the flows go up, the energy of that system goes up, the flows will spread out on the vegetated floodplain. They're protected from the high energy of those flows. They'll slow the flows. And this can be designed. We typically see that the minimum width of the second stage, so that remains sustainable, is about 3 times the width of that inset channel. If you can get this higher towards 5 times the channel width, that's better. More natural systems would often have 10 times or more. But we understand that people don't want to give up this ground up here. So there's kind of some minimum recommendations, which would be about 3 times the bankable width for that second stage at a minimum. If you wanted to contain larger flows within that second stage, you could build it larger, and that's an option. But that's essentially the 2-stage channel design. Yes? Oh, good. Yeah, please welcome questions if people have questions. Feel free.
How do you determine so you said you could have it 3 times as larger or larger flows, and we're thinking about changing rainfall patterns and different types of weather. How did you determine that 3 times?
That's been just observed in nature a lot of times, where we find these things that form naturally on their own because somebody built a trapezoidal ditch that was too wide. Usually that second stage is about at least 3 times as wide as the inset channel. So I guess that Dan was involved in a lot of that. He actually wrote a paper on this, so maybe you can add a little bit to it. But it was basically, a lot of it was based on observation of what was occurring in nature.
Yeah, while we see the forming in some narrower ditches, we also see not forming something pretty with what we might have on as a reliable number. So this is with kind of a minimum threshold in the stream classification. So just above where the bad channels are, just into where the good channels are. I'm
not going to spend a whole lot of time here. So So obviously we're here to tell you about the two-stage ditch practice, but I'm not going to sit here and tell you that they're going to solve all of your drainage problems, all of your water quality problems, make everybody hold hands and be happy. But I do think there are many places in the landscape in the Midwest where these could be very beneficial. And if you look in your the folder you got, there's some information in there. On the left side, you should have information about selecting between some of these methods you hear about today, when they're most appropriate. Then if you look on the right side, there should be a printout from the Ohio Country Journal, and then a fact sheet. We actually included a couple fact sheets that we're going to have published through the Great Lakes Regional Water Program. They'll be ready in about 2 weeks and up on a website, but we didn't have those finished today because we didn't get them to them soon enough. But the text and the figures for those are included, so you can learn a little bit more about these trade-offs by reading through that. But each of the methods today, the trapezoidal, the two-stage, the self-forming, and the natural channel design, there would be trade-offs in the amount of land required for each one of those, the cost to construct those, the maintenance frequency that you might need to go back in and improve these things. There would be different amounts of environmental benefits and stability with each of these systems that really needs to be considered. But luckily, there's a lot of tools to do this sort of analysis. We have a lot of great engineers at places like NRCS, SWCD, at universities, consultants that know these tools or have the training to pick them up quite easily to do these sorts of analysis. So we'll share a few of those with you today. But I do want to point out that there are lots of trade-offs when selecting between these, and I know places like the Army Corps, you often evaluate several methods to improve a situation. Other places, that process may not occur as much, but there are trade-offs, and hopefully we'll bring some of those to light today. Here's the very first two-stage ditch that I know of that was constructed. It was a project with the Nature Conservancy up in Hillsdale, Michigan, about 15 minutes north of Pioneer, Ohio. On the very left, you see what the ditch looked like pre-construction. Little areas of bank instability. I think the primary problem was a lack of capacity. You can see right during construction on the upper right, it always rains right when you're in the middle of a construction project to make you worry. The benches were fine. About a month later, they started to grass and vegetate. 6 years later, pretty robust system, maintaining itself very well, lots of vigorous vegetation. Sarah's going to show some pretty impressive water quality results associated with this ditch here later on, I believe. Creel Ditch, this is a ditch that went in about 3 years ago in Indiana, northeast Indiana. Another project of the Nature Conservancy, I believe, with the Joyce Foundation. If you see that, if you haven't seen it, there's a nice video. It gives you the perspective of the landowners, some of the university researchers, and the Nature Conservancy talking about the various, some of the various projects. This one and another one called Shadow. Once again, it storms and floods out as usual. This system today is doing quite well. So just a couple of examples of two-stage ditch projects. The last thing I want to share here, this is a map from about 2 years ago. The planned ones are in blue. I'm pretty sure most of those have actually been constructed, and there's probably another 10 or 20 that are in the planning stages or have been constructed. So I would say, do you think it's fair, Carrie, to say there's between 40 and 50 now, and a lot of the work's going on in Indiana?
I just wondered, since you brought that up, if somebody is keeping up that map. Somebody just at the meeting I was at yesterday asked, who was in this, and I said it must be the Nature Conservancy. Is that right?
There's a lot of phone calls going on to ask where in the green to put it on there. So are you doing it? And definitely not.
Yeah. Andy Ward gave a presentation to NRCS in Indiana, about 1 or 2 years ago. Up until that point, we had been involved in almost every project that there was. So we had a pretty good idea of where everyone was on the landscape, and now we get calls saying, hey, do you know there's a ditch, you know, in this place? So they've just taken off with it. And actually the feedback we're getting as they go through their process is really important as we move forward to try and improve some of the design guidance we do. I don't want to take any more time. I want to let Dan get up here.